All right, let's dive in. Today, we're stepping onto the factory floor. But, this isn't your grandfather's factory. We're talking about the super high-tech, high-stakes world of modern industry. It's a world that runs on data, on precision, and on just insane efficiency. And right at the heart of it all is a single, really revolutionary question.
I mean, it sounds a little bit like sci-fi, doesn't it? A system that can literally see the future and then act on it. But we're not talking about predicting stock prices or anything like that. We're talking about preventing catastrophic failures, saving millions of dollars, and building a way smarter, more resilient industrial world. And believe it or not, this one question is the key to unlocking the whole thing. So to really get why this is such a game changer, we first have to understand the biggest challenge that basically every factory on the planet faces. It's a huge, huge problem, but it's one that's usually hidden right in plain sight.
You've got to think of it like an iceberg. You know the saying, right? The problems you can actually see in a factory, the loud alarms, the sudden breakdowns, that's just the tip. The real danger, the part that's truly, truly expensive, is that massive, hidden chunk of ice lurking just below the surface. These are the invisible problems. Let's break that down. Visible problems are pretty obvious, right? A machine just grinds to a halt. A big red light starts flashing. A product comes off the line looking wrong. In all those cases, you're just reacting to something that's already happened. But the invisible problems, oh, they're much sneakier. We're talking about a cutting tool wearing down by a few microns, a machine that's quietly sucking up extra energy, or that silent, growing risk that a key part is going to fail next week. You can't see them, but they are the real culprits.
And you better believe these invisible problems have a very, very visible cost. We're talking about an estimated $50 billion in losses every single year. And that's just from unexpected shutdowns. That is the staggering price tag for not being able to see what's just around the corner.
Okay, so if the problem is that things are invisible, the solution has to be some kind of superpower, right? The ability to see what nobody else can see. And that's where the hero of our story comes in: industrial AI. Now, this definition is so important. Industrial AI isn't just about taking some fancy algorithms and throwing them at a pile of data. It's a systematic discipline. Its entire purpose is to take those invisible issues, that gradual wear, those hidden costs, and drag them out into the light so they can be managed. And you really got to pay attention to that last part. It always, always starts with the problem, not with the tech or the data.
And this brings us to a really, really critical distinction. We all hear about AI constantly, things like ChatGPT or the algorithms on social media. But industrial AI, it's a completely different animal. It's built for a totally different world. Let's break down exactly what makes them so different.
So here's the core difference. General AI is driven by opportunity. It asks questions like, hey, what new ad can I show you? Or what video might you like next? Its goal is divergent. It wants to open up a bunch of possibilities. Industrial AI, on the other hand, is driven by a problem. It asks, how do we stop this one specific machine from breaking down? Its goal is convergent, to narrow things down to one single reliable solution. The focus isn't on keeping you engaged, it's on performance. Because, well, in a factory, you can't afford to be wrong. Jay Lee, the author behind our source material, he just puts it perfectly. He says, in the past, AI applications looked for hidden relationships in data, whereas industry needs to begin with problems and create value by creating solutions. And that's it, right there. That's the fundamental shift in thinking. It's moving from just exploring data to laser-focused problem solving. And that is the real power here. Okay, so that's the theory. But what does this actually look like in the real world? How does industrial AI go from just being a concept to actually making problems, well, vanish from a factory floor? So let's look at a case study from Foxconn, the company that makes a ton of the electronics we use every day. We're going to focus on this tiny, seemingly insignificant part, a suction nozzle. Its job is to pick up and place these minuscule electronic components onto a circuit board. If this little nozzle fails, the entire production line just stops. So how does this all work? Well, first, the system collects data in real time from every single nozzle, and each one has its own unique ID. Then an AI model crunches all that data. It's not just looking to see if it's working right now. It's trying to predict its remaining useful life. And finally, this is the magic trick, the system acts proactively. It doesn't wait for some alarm to go off. It actually tells an operator, hey, go replace that specific nozzle right before it's predicted to fail. And the result of this proactive, predictive approach, it's just staggering. A 66% reduction in material costs and waste. By solving an invisible problem, the slow breakdown of a filter, they created this massive tangible value. It's incredible. Now, this case study, it isn't just about one little nozzle. It's really a stepping stone to a much, much bigger vision. The ultimate goal of industrial AI is to create what our source material calls the worry-free factory. This whole vision is built on reducing 3 key things. First, reducing physical waste. Next, it's about reducing tedious manual work by using smart automation. But the ultimate goal, the real endgame, is reducing worry. It's about using AI to manage all those hidden uncertainties to finally achieve the holy grail of manufacturing, 0 downtime and 0 defects. You're building a system so reliable, you can finally stop worrying about it. So what all this really represents is a fundamental shift in how decisions get made. We are moving away from an economy that's based on experience, where the veteran manager makes a gut call, to an economy that is based on cold, hard evidence. The decisions are driven by data, by models, and by predictions. And this brings us right to the ultimate philosophy behind industrial AI. It's not just about getting better at fixing things when they break. No, it's about building a system so smart that things don't break in the first place. As the thinking goes, the real purpose isn't just to solve problems, it's to make them completely cease to appear. So I want you to just think about this for a second. If we can teach a factory to see into its own future and prevent its own invisible problems, what comes next? Just imagine applying that same proactive, predictive power to our hospitals, to our city infrastructure, or to our power grids. What invisible problems could we finally solve there? The potential is just absolutely immense.